So I think we can quickly look at these questions. The answers are there, but how did they arrive at these answers? And I'm not sure all the answers there are correct. So we're going to start now. So the first question says, what's the measure of inertia? This is correct. Measure of inertia is mass. The second question, we have this force acting on a body with a mass of 0.75 grams. Find the acceleration. How do we go about this? So don't forget that we said we can put our calculator in complex mode, then input all of this. But you see that this is I and this is J, so we enter I as nothing. So we are going to have 5.5 plus, then we enter 2.2 as I, shift I, then plus the second force is 4 plus what, 6I, plus next one is what, 2.5 plus 6I. So this is the total force acting on the body. Then we divide that by the mass. So it's going to be divided by 0.75 exponential minus 3, convert it to kilogram. So this is going to be the what? This is going to be the force. Well, we need the magnitude. So shift complex 3. So that's what, 247852. So this is going to be the what? This is going to be the magnitude of the acceleration that is acting on the body. Now I've divided it by the mass. So when you divide when you divide force by mass, it gives you acceleration, because it's acceleration that you have to find. So the answer should be 24788. So the next one, relationship between stress and strain. So stress and strain, what connects them is Young's modulus. So Young's modulus is what? The stress divided by the strain. So anyone that contains this option is going to be the correct answer. Young's modulus is stress over strain. Let's see. Strain is stress over Young's modulus. Let's check. Strain, this is strain, that's stress over Young's modulus. That's correct. So this is correct. Which of the following represent the equation of continuity? Equation of continuity is the flow rate is constant. The flow rate is going to be constant, and flow rate is AB. So we have A1 V1 is equal to A2 V2. That's the equation. So B is correct. What's the SI unit for moment of inertia? Moment of inertia is what? mr square. So this is kilogram, this is meter. So it's going to be kilogram meter square. Which of these is not among the equations of motion? We have v square is u square plus 2s. We have s is ut plus rvt square. We have v is equal to u plus at. But I've never seen s is v plus u times t. There is no such equation of motion. The one that there is v plus u over 2 times t. Now, where some people will get it wrong, although you are not supposed to get something like this wrong, where some people will get it wrong is by checking the dimension. They think that this is meter per second. Is it not meter per second, and this is second? So cancel out. We have meter, which is the unit of distance. You are wrong. So the equations of motion are equations that we know. So is not, this B is not part of them. So which of these gives a water droplet its shape? The answer is surface tension. Cohesive force is an what? Expansion between molecules of the same substance. This should actually be cohesive force is attraction between molecules of the same substance. That's the answer, not expansion. So what is lattice? Lattice is actually the three-dimensional arrangement of molecules in an atom. That's what you call a lattice. The arrangement of molecules is what you call lattice, and the arrangement is usually regular. in crystalline substances, it's going to be a regular arrangement. So we want to find the magnitude of a vector. How do you denote it? You denote it with two vertical bars. That's correct. So if you have vector A and you want to know the magnitude of A, this is how you write it. So this is correct. The next one, which of these is not a Newton's second law of motion? F is ma, F is mg, A is the v dt. Now I don't agree with this answer that F is equal to mg, because F is equal to mg and F is equal to ma are the same thing. Both of them are saying force is mass times acceleration. This is also saying force is mass times acceleration, because Newton's second law of motion states that the rate of change of momentum is what? Is proportional to the applied force. And when you finish it up, you get F is equal to mv minus u over t. This is what you get. Or you get F is equal to ma. So it's either it is this or it is this, right? Is there any point here where they mention that acceleration is the v dt as part of Newton's second law? No, it's not. Newton's second law is that what? The rate of change of momentum is what? Proportional to the applied force. And that let me think about this again, because if you say the rate of change of momentum is proportional to the applied force, and by the time you did it, you got F to be equal to ma. That means that you are saying that the force is proportional to the acceleration, right? Yes, the force is proportional to the acceleration. So I will still go for C. The answer should be C, because there's no point there where they said the acceleration is changing velocity over time. There's no point. They only said the rate of change of momentum is proportional to the applied force, and it corresponds to both option A and option B. So which of the following is not a unit of time? Tons is a unit of mass, so that's not correct. So the angle of contact for a liquid that rises in a capillary tube is what? If a liquid is going to rise in a capillary tube, when the liquid is placed in the tube, it's going to have a concave meniscus. That means it's a curve inward, something like this. So if you want to know the angle, what do? You draw a tangent at the point of contact. So you draw a line like this, then you measure the angle between this line and the wall. Look at this angle, it is less than 90. This is 90 degrees, so this angle is less than 90. Angle that is less than 90 is what? An acute angle. It should be an acute angle. So the next one, what will be the range at maximum height? What's going to be the range at maximum height? That means when the height is maximum, what will be the range? Height is what? U square sine square theta over g. This is height. So when the height is maximum, that means you remove this, right? So let me check the option again. It says u square over g. This person have misplaced it, because here if this is going to be 1, that means theta is going to be 90. So you go to the formula for range. Range is what? U sine 2 theta over g. Sorry, u square sine 2 theta over g. So this will become u square sine 2 times 90 is what? 180, right? Over g. So this will give you 0. So that means the range at maximum height is supposed to be 0 and not the other way around. The only way that answer will be correct is if they ask for the height at maximum range. That's when it's going to be correct, because at maximum range your r is supposed to be u square sine 2 theta over g, right? So if r is maximum, that means this is not there. If this is not there, it means 2 theta is 90, then theta is 45, right? So if theta is 45, now go and put it inside this formula, and it's still going to be wrong. So that will be u square over g, then sine 2 theta, sorry, sine square theta. So theta is what? 45. So it's still wrong. So u square over g multiplied by sine 45 is root 2 over 2. When you square that, you have 2 over 4. So the answer was u square over 2g. It's going to be u square over 2g. So that answer is wrong. So the height, the range at maximum height is what? Is 0. When the height is maximum, the range is going to be 0. That means the object is projected directly vertically upward. But when the range is maximum, the height will not be 0. The height will be what? U square over 2g. So that should be the answer. The answer should be 0. So what's Bernoulli's principle? The sum of pressure, potential energy per unit volume, and kinetic energy per unit volume is constant. That's correct. Dimensions help to derive equation. That's true. But dimension helps to do many other things also. It's not only to derive equation. Use dimension to derive equation, to check the correctness of equation, to know if two or more particles are related. So there are many things that you do with dimension. So it's not only to check correctness of equation, but maybe because this is the one that is in the option, that's why they decide to pick this. So which of these is not true of inelastic collision? For elastic collision, the kinetic energy is going to be conserved. So that means that total kinetic energy before collision is equal to total kinetic energy after collision. So that means if the collision is inelastic, then they can't be equal. So this is going to be wrong, because this will be correct only if it is what? Elastic. So for the period of pendulum given by this, find the max value of x, y, and z. So they said m raised power x, l raised power y, m raised power x, l raised power y, g raised power z. So find the values of x, y, and z. So when t is the period. So what they want you to do is the formula for period. Formula for period is 2 pi root l over g. So this is going to be 2 pi then l raised power 1 over 2, g raised power minus 1 over 2, and I think there should be k here. There should be k here. Maybe the person forgot, the person left it out. So because t is not just the product of this, there is a constant which is 2 pi. So what do? We compare. Let's add m to it, so there will be m raised power 0. So you compare for m. The power of m is x, the power of m here is 0, so that means x will be 0. The power of l is y, the power of l here is 1 over 2, so y will be 1 over 2, and z will be what? Minus 1 over 2. So those are the answers. The next one, if a mango falls from a tree, given that g is 10 and the height is 10, find the time it takes to fall. So what are we going to do? The time it takes to fall, they've given us the height as 10, they've given us g as 10, so we are looking for the time. So we are going to say s is ut plus half gt squared, because it's falling, so the velocity will be increasing. That's why we are using plus. So it falls from rest, so that means this will be 0. So we are going to have 10 equal to half times 10 t squared. So this will go, we are left with t squared is equal to 2, so t will be square root of 2, which is 1.414 or 1.414, so 1.43. okay, it should be 1.414. So why are raindrops spherical in shape? So the reason they are spherical in shape is because of surface tension. That they are spherical in shape. So the next one, when cohesion is greater than adhesion, the reference gives a convex meniscus. Is that true? When cohesion is greater than adhesion, a good example of where cohesion is greater than adhesion is mercury, and in a glass tube, mercury is going to fall, so this is going to have a convex meniscus. This is curving outward, so it is correct that it gives a convex meniscus. What's the dimension of power? The dimension of power is work done per unit time. Work done is force times distance over time, or force times displacement, not distance, force times displacement over time. So this is kilogram meter per square second multiplied by meter divided by second. So kilogram meter per square second is for force, meter is for displacement, then time is second. So this will become kilogram meter squared per second cube. So that will be what? Kilogram is for mass, m is for length, and t raised power minus 3. So it will be ml square t raised power minus 3. So that answer is also correct. So the next one is SI unit of viscosity, of coefficient of viscosity, Pascal second. Is that correct? Coefficient of viscosity, you get it from stress. The tensile, the shear stress is coefficient of viscosity dV dy. So that's the velocity gradient. This is stress, which is in Pascal, equal to this is meter per second divided by meter. So you have per second. When you take it to the other side, it becomes second, so it becomes Pascal second. So that is correct. So wind blowing in a small room and parlor, the wind blows out the curtain but does not remove the asbestos. The solution of which principle? That's Bernoulli's equation. So the formula for flow rate is what? If the cross-sectional area is A and the average speed is V. So we do it the way we did the previous one. Flow rate is the area multiplied by the velocity. So that answer is correct. So stress leads or causes stress. Stress can cause strain. Stress can cause deformation. Stress can cause compression. So that means that strain and deformation is correct. Strain and compression is also correct, depending on which kind of stress. So that means that this question has some amount of ambiguity in it. So that means that we need to know what kind of stress they mentioned in the question. So if the question mentioned longitudinal stress, or they mentioned axial stress, then the answer is going to be compression. Longitudinal stresses cause compression, and at the same time, do they cause strain? Yes, they cause strain, because strain can be of two types. You can have normal strain. You can have normal strain, and you can have shear strain. So it's either you have a normal strain or you have a shear strain. So if you have a longitudinal stress, it's going to cause normal strain. But if you have a shear stress, then it's going to cause shear strain. So it depends on what they say the stress is. So let's assume that they say this stress is an axial stress, or they say it's a longitudinal stress, or they say it's a tensile stress, or they say it's a compressive stress. The general name for all those ones I just mentioned is what? Is axial stress or longitudinal stress. So if that is the case, then we are going to pick strain and compression. We are going to pick strain and compression. And we can also pick strain and extension, depending. So if this is axial stress, then we are stuck between picking either strain and compression or strain and extension, because longitudinal stress can either be tensile or compressive. It's either it is tensile or compressive. If it is tensile, then it causes extension. If it is compressive, then it causes compression. But if the question says it is compressive stress, then it's going to be compression and strain. If the question says it is tensile stress, then it's going to be strain and extension. But if the question says it is what do we call it, shear stress, then it's going to be strain and deformation. It's going to be strain and deformation. So those are the cases that we can have. Then what's the SI unit of energy? Energy is measured in joules. So what's the unit of viscosity? Pascal second. What's the unit of impulse? Impulse is Newton seconds or kilogram meter per second. What is the unit of surface tension? Surface tension is Newton per meter. The dimension of viscosity, this is actually correct, ml inverse T inverse. From here you can get it. Viscosity is Pascal second, and I think if you simplify Pascal second, Pascal is Newton per square meter, right? So that's going to be kilogram meter per square second per square meter multiplied by second. So this cancel out, this cancel this. So you have kilogram per meter per second. So this is ml inverse T inverse. So that's correct. What are the forces that act on the body falling through a viscous fluid? So the forces are the weight of the body pulling it down, the up thrust trying to take it back up, and the drag force. The drag force. Yes. Although the drag force should be due to viscosity, I would have called it viscous force. I'll call it viscous force because I can only call it, you can only call it drag force if the body has attained terminal velocity. If the body has not attained terminal velocity, it's better you call it viscous force and not call it the drag force. So what's the formula for drag force? The formula for drag force you can see now. So the formula for drag force is actually 6 pi coefficient of viscosity multiplied by the radius multiplied by the terminal velocity. So this V is the terminal velocity. So you can't use it until the body has attained terminal velocity. That's when you can use this formula. So the SI unit of buoyant force, it is still a force, so it is Newton. So the total force needed to overcome frictional force at rest. I don't understand what this question is trying to ask. The total force needed to overcome the frictional force at rest. I don't understand the question. It's not complete. So surface of liquid in plane, angle of contact of the liquid with the walls of the container is 90 degrees. Somebody actually sent me this question, that if the surface of a liquid is flat, what's going. So the angle of contact, don't forget what we did. Have I cleaned it? So this is the angle of contact, right? So if the surface of the liquid is flat, then you have something like this. Then the liquid surface is flat. So we have this is the surface. So you want to draw a line that is parallel to the surface of the liquid. You still draw this line. So you now measure this angle. So the angle is going to be what? 90 degrees. So the next one, we have apply force of 15 Newton at 30 degree. The work done when the cars move 12 meters along its own direction. And the problem here is that we don't know which direction the car is moving, because the answer we are going to get for this depends on the diagram. The answer depends on the diagram. Let's assume that this is the car and this is the floor, and the car is moving this way, and this is the force. So this force is 15 Newton and the angle is what? 30 degree. So if the car is moving along this direction, then the work done, the work done is the force multiplied by the perpendicular distance, right? So the perpendicular, no, sorry, work multiplied by the displacement, the force multiplied by the displacement. So that's going to be, we need the force in this direction, so that will be the horizontal component of this force. So that's going to be 15 cos 30 multiplied by, what is this distance? So if it's moving along that direction, that distance, so we assume that that distance, it is that 12 meter is along this distance. So you multiply by 12. So we assume that this is 12. So we are going to say 15 cos 30 multiplied by 12. What's that going to give us? So we have 15 cos 30 multiplied by 12. So the answer is what? 155.88. 155.88. So 156. But that's just an assumption, because it's possible that the car is also moving this way. It's possible that it's moving this way. So if it's moving this way, then you have to do 15 sine 30 multiplied by the displacement. So since we are not sure which direction the car is moving, they are just saying the car is moving along its direction. Along what is its direction? Which direction are you saying? So, well, this is just an assumption. The question is not clear. So a stone of 5 grams is vertically thrown upward with a velocity of 20 meters per second. The kinetic energy at maximum height. What's going to be the kinetic energy at maximum height? So the mass is 5 grams and we throw it up with a velocity of what? 20 meters per second. So at maximum height, where we have to find the kinetic energy. So the kinetic energy at maximum height Wait, the question mentioned maximum height. That's going to be 0, because at maximum height the object is no longer moving, so we don't even need to solve anything. So since the question is the kinetic energy at maximum height, the object is at rest, so it is no longer moving, so the kinetic energy will be 0, not 1. So which is true about viscous liquid? They find it very difficult to flow. That's correct. An object of mass 0.02 kilogram is thrown to a height of 40 meters and returns to the ground. The kinetic energy when it returns to a point where it was projected. What's going to be the kinetic energy when it returns to the point where it is projected? Okay, so the mass is what? 0.02 kilogram, and the height is 40 meters. It is thrown to a height of 40 meters, so the mass is 0.02 kg, and the height it reaches is 40 meters, right? So we have to find the kinetic energy. Now when it reaches the top, it is going to stop. That means that all of the kinetic energy have been converted to potential energy. Now we are supposed to look for okay, when it returns to point where it was projected. So this is going to be, that means that you can use formula for potential energy, because at the top all of the kinetic energy has finished. It is now left with potential energy, and by the time it returns, all of the potential energy has finished. You are now left with only kinetic energy. So this will just be mgh, 0.02 multiplied by 10 multiplied by 40. So 2 zeros we go, 2 times 4 is 8, so that's going to be 8 joule is actually correct. So number 43, a spring stretches 0.15 meters when a mass of a spring stretches 0.15 meters when a mass of 4.3 kilogram is attached to it. So we use these first two conditions to get the spring constant. Now the spring constant, the mass is what? 0.3 kilogram, and it stretches 0.15 meters. So with this you can get K. So using F is equal to KE, since it is the weight that is stretching it, we say mg equal to KE. So that means that K will be mg divided by E. Did they give us value for G? Nope. So let's use 10. So we say the mass is what? 0.3 times 10 divided by 0.15. So 0.3 times 10 is 3, so 3 divided by 0.15, that's going to give us 20. So our K is going to be what? 20. So the question is now to find what? Our K is 20. The question is to find the maximum velocity, and they stretch it 0.1. So that means our amplitude is 0.1 and our K is 20. Find the maximum velocity. So we use V is equal to what? Omega A. Now omega is omega root m over K or root K over m? I'm not sure the value of omega.